This year's 100,000 euro Einstein Foundation Early Career Award goes to Maximilian Sprang, bioinformatician and junior group leader at the University Medical Center Mainz. With his project erring rigorously to make genomic research more reliable and reproducible, he tackles a key challenge in modern bioscience, revealing how errors in high-throughput sequencing affects results. Congratulations on receiving the award and on standing out among more than 70 global applicants. Dr. Sprang, what are the main goals you hope to achieve with your project?
So the main goals, you already mentioned it, like revealing how errors in high-throughput sequencing affect the results. So we really want to learn more about the sources that bring these biases into bioscience, right, or into functional genomics, to be more precise. And then in the long run, we hope when we learn more about how these biases are actually introduced, we hope to be able to correct them better, right? And then also reveal new biological signal in data that has been already used and where the signal was potentially hidden behind a bias.
So why do you think your project matters, and specifically to whom does it matter?
Would actually switch that order around. So it matters to all people that use RNA-seq, right? And this brings it to why does the project matter? Because RNA-seq is used all over life science. It's used from plants over animals to humans. And nowadays, functional genomics, especially RNA sequencing, is also pushed more and more into the clinical setting, into translation. And here it's even more important to know if there is a bias in the data, in the signal, and potentially correct it.
That sounds challenging. So what do you anticipate with respect to hurdles in the project, and how do you plan to tackle them?
So from my point of view, there are two really big potential hurdles or challenges. The first is that the errors that we introduce are not strong enough, or their impact is not strong enough that they change a lot in the biological signal. And the second one is we plan to use our established quality control software, right, SecuScorer, and that this software cannot pick up some of the signal or impact that is introduced to these errors. The first we already tackle with the experimental design. So we plan to really aim for errors and changes that we expect to have a strong signal, like changes in cell culture density, for example, or directly interfering with the integrity of the RNA. And the other part of the problem can be tackled by improving the software, of course. So if we see, okay, we know these impacts or these changes should impact strongly, right? And we see the software doesn't pick it up, then we have to improve it. And we can change the model. We can try to find more data to train on, stuff like that.
Now, looking ahead, what impact or changes do you hope your project could bring about?
The most immediate impact would be the data set itself, I think, because it could be really a potential standard data set for all these softwares that try to tackle this problem. And there are already a lot, and there will be more in the future. I'm quite sure about that. And so this will already be very valuable for the community. And in the long run, what could be really a strong impact is if we learn, or if we can use this knowledge that we learned about where these biases come from to correct them better, and therefore learn more about biology from the data that we already have.
Now, if a fairy would approach you and give you one wish free, so how to improve the academic world, what would you wish for?
I mean, there is a lot of problems with academia, especially for early career researchers that are already discussed a lot, right? Like the publish or perish paradigm. You need to be very mobile if you want to be a professor, especially early. And this can be a problem if you started a family early, like we did. However, for me, like my biggest wish, so to speak, and I think this would also impact these other things, that's why I mentioned them, is that instead of only looking for excellence, I mean, excellence is obviously important, right? We all want to do excellent science, right? But instead of only looking for excellence for potential leadership in science, we should also look for kindness. We should look for respect, especially for the students, especially for the people that work with them. And I say this because I was very fortunate. I was always treated with a lot of respect. I was treated as an equal from day one in my PhD studies, even as a master Hiwi, right? And I wish that for others too. And sadly, I see a lot of the opposite. A lot of people that really suffered through their PhD, which should have been a scientific journey. And in the future, if I make it into scientific leadership myself, I hope to be part of that change.
I couldn't agree more, and I'm quite sure if there would be such a fairy, she would grant you this wish. So thank you very much for talking to us, and congratulations again to winning the award.
Thank you.